Hello guys, let us now proceed further. We know that sine theta and cosine theta are the ratios of opposite. Now here ABC, my B is a right angle and this angle is theta. So sine theta is equal to AB upon AC, cos theta is equal to BC upon AC. Now people say that maximum value of sine theta can be equal to 1 and maximum value of cos theta also can be equal to 1, correct? But what is the justification of that? My sine theta, okay, it is opposite upon hypotenuse, correct? Now here just consider that theta is equal to 0 degree, okay? So if theta has to become 0, right, that means my hypotenuse will come closer and closer and closer and closer to this side BC here, and that means so theta will be 0 when this AC coincides with BC, correct? In that case, what would be the length of opposite side? Will it not be 0? That is the reason why sine of 0 degree is 0. Now again, what about cos of 0? They say cos 0 is 1. How can we say that? Now what is my cos theta? It is the ratio of adjacent side to the hypotenuse. And what is my adjacent side here? Adjacent side is BC. So when my theta becomes 0, my hypotenuse comes closer and closer and closer and closer to this side BC, and that means at theta equal to 0, hypotenuse coincides with my adjacent side. So it is going to be either BC upon BC or AC upon AC, and that is the reason why cos of 0 degree is equal to 1. So likewise we can think about why my sine of 90 degree is equal to 1. Now here, if my theta becomes 90 degree, that means my hypotenuse moves like this in this direction, and now when my angle theta becomes 90 degree, in that case my hypotenuse is going to become my opposite side, and that is the reason why sine 90 degree is equal to 1. Obviously when my theta is 90 and my opposite side becomes hypotenuse, what is going to be my adjacent side? Is it not going to be equal to 0, right? So cos of 90 degree is equal to 0. So you must have seen that the value of or magnitude of sine and cosine, they lie between 0 and 1. Okay, so actually can this sine and cosine take negative values? Yeah, the answer is yes, but then that we would be able to deduce when we consider a unit circle. What is a unit circle? Unit circle is a circle having radius equal to 1 unit, correct? And we will be proving that later, but then for now what you can understand is -1 less than or equal to sine cos theta less than or equal to 1, and -1 less than or equal to sine theta less than or equal to 1. Now again, there is one more reason. My hypotenuse in any right angle triangle, hypotenuse is the largest side and the other two sides, they are definitely smaller than the hypotenuse, and that is the reason why my sine theta and cos theta, they are always going to be less than 1, because the denominator is greater than the numerator, correct? So this I would say magnitude of cos theta less than or equal to 1 and magnitude of sine theta is again less than or equal to 1. magnitude, or I would say modulus, but I'm particularly not using modulus word because so far we have not touched that part. Okay. Now that was about the basics and the justification or logic, whatever you call it, about the values of sine theta and cosine theta. So now I'm going to write a few formulae which we will be using very widely here in trigonometry. The first one is cos of a plus b is equal to cos a cos b minus sin a sin b. Now if I change this sign here, I make it minus here, then there will be plus sign here. Okay, so cos of a plus b is cos a cos b minus sin a sin b, and cos of a minus b is going to be cos a cos b plus sin a sin b. Now sin of a plus b is equal to sin a cos b plus cos a sin b. Okay, and of course I add one negative sign here, then this will become negative there. Correct. So in all we have 4 formulae. Correct. We also have tan of a plus b is equal to tan a plus tan b upon 1 minus tan a tan b. Now these are again I have one more here, so I add I want to find tan of a minus b, so then this plus will become minus and this minus will become plus. Correct. So in all, how many formulae we have? We have 6 formulae. Now the thing is, I am saying that these are the formulae, but then if I say something, I must prove it. Correct. How do I do that? And it's not going to be a very difficult exercise. It is going to be a simple exercise. The diagram might appear to be little frightening, but don't get frightened. Okay, believe me, it is going to be a really simple thing to do. I'll do it in some time. I'm going to draw one unit circle. Even if it doesn't look like a circle, it is a circle, and the radius of this circle is equal to 1 unit. This is my x-axis, and of course this is my y-axis. Now I'm going to take one angle here. Let us call this point as A, and or I'll take this point as P here, and one point Q here. Okay, why am I doing that? So now I need to specify the angles. Correct? There is some reason behind doing this. So this angle is angle A. This angle is angle B. Now this point is my point. Let us call this point S. This is P, this is Q. I'm calling this S. Why S? Where are Q and R? They will be there. Okay, now my XOP, angle XOP is angle A. Measure of that angle is A. Angle XOQ is B. So obviously my bigger angle minus smaller angle, right? My bigger angle minus smaller angle, that is angle POQ. So angle POQ is A minus B, correct? Alright. But now, I wanted to find cos of A minus B there, correct? How am I going to be able to do that? Now let us do something. Let's do some construction here. I'll have one angle XO somewhere here, R. Okay. So now I have P and Q and R and S here. Okay. My angle XOR. Now that angle I am going to take equal to A minus B. Angle XOR now how does that help me? See, my angle POQ is A minus B and angle XOR, that is A minus B. Now it is a unit circle, right? So what are the coordinates of S? So coordinates of S would be obviously 1, 0. Correct. So I am going to write that too here. My point S, its coordinate are 1, 0. What about the coordinates of Q and R and S? Now here, in a unit circle, when the angle is theta, right? When angle made by position vector of a point P, if the angle is theta, then the coordinates would be cos theta and sin theta for a unit circle, isn't it? So now here, my coordinates for P would be, now angle made by P with the positive x-axis is A. So my P would be cos A, sin A, and my Q, that angle made by OQ with positive x-axis, it is B. So my Q is going to be cos B, sin B. Okay, angle made by OR with the positive x-axis. So my R is going to be equal to cos of A minus B. That angle is A minus B. So I'm going to have coordinates as cos of A minus B and sin of A minus B. Okay, and what about S? S, the coordinates of S I already have. Correct. So now I am going to do some more and some simple construction here. I'll have this chord PQ and this chord RS. Okay. My angle POQ and angle ROS, are they not same angles, congruent, right? So if two angles, the length of chords cut by congruent angles with the center of the circle, they are same. So I can say that PQ is equal to RS right? So obviously PQ square is equal to RS square. Now we know the coordinates of P and Q and R and S here. Here can we apply distance formula? So of course we can, and let us write let's write the expressions for that. So PQ square, now what is my P? So it is difference in the x coordinates and square of that plus difference in y coordinates and square of that. So PQ square is going to be cos A minus cos B whole square plus sin A minus sin B whole square is going to be equal to R is square. So square of this minus square of this minus this minus square of this, square of this minus square of this. So it is going to be cos of A minus B minus 1 square minus sin of A minus B minus 0 square. Okay, now here I am going to write, now I'm going to write in one single line. Just I'll try to keep it as clean and simple as possible, and I'll be using different colors wherever needed, but then just be careful in watching what I'm doing here. Okay, so cos of A square is cos square A plus cos square B minus 2 cos A cos B, correct? This is square of my first term plus sin square A plus sin square B minus 2 sin A sin B is equal to square of this. So cos square A minus B plus 1 minus 2 cos A cos of A minus B, and here my second term is 0, so it is obviously only sin square A minus B. Now using the basic trigonometric identity, cos square theta plus sin square theta is equal to 1. So now cos square A plus, I forgot writing A here. Okay, so cos square A plus sin square A, that is equal to 1 plus cos square B plus sin square B, and again that is going to be equal to 1. So it is 1 plus 1 minus 2 cos A cos B minus 2 sin A sin B, correct? So 2 I am going to take common, so that is cos A cos B. Now I am going to take minus 2 common, so it is going to be cos A cos B plus sin A sin B correct? So that is my left hand side. Now here 1 plus 1, shall we write 2 over there instead of writing 1 plus 1? I'll write 2 here, correct? Now what is my right hand side here? My right hand side is equal to, again if I take this and this, so cos square A minus B plus sin square A minus B is going to be equal to 1. So 1 plus 1, so that is equal to 2. Now it is going to be 2 minus 2 cos A cos of A minus B, correct? So 2 I am going to get going to take common, and that will be equal to so it is 1 plus 1, that is 2. So 1 minus 2 cos of A minus B. Correct? Now I'm going to divide by 2, and I see 1 2 here, 1 2 here, 1 2 here, right? So I can cancel my 2 here. So what I'm going to have over here is 1 minus cos A cos B plus sin A sin B is equal to 1 minus cos of A minus B. Correct? I'll just get rid of this 1 here and 1 here. I can as well get rid of this minus sign here, and then that gives me my I would say most important result in trigonometry, or maybe little less than that anyway, but then I find it amazing. Okay, so it is cos of, I'll just write it here, I don't have much space left over there, so cos of A minus B is equal to cos A cos B minus sin A sin B. What we did, we just used some basic trigonometry, some basic geometry, basic coordinate geometry, isn't it? Because what we have done here is we just wrote down the coordinates and just applied distance formula, isn't it? And here we are, right? Now in the next part of this video, I'm going to talk about the other formula as well. Thank you.